Welcome, everybody. This is the Impossible Metals April webinar and podcast. Delighted to have Justin Manley giving this month's presentation. It's a repeat of Justin did give us a presentation, I think, almost 2 years ago. I have to check the exact dates. It was one of our most popular webinars of all time. So no expectations, but it was incredibly well received. And so I'm really excited for Justin to talk about trends in marine robotics, defense, and dual-use drivers of the dynamic industry. Just briefly on Justin, he has an incredible career, but the way I think of him as he is the expert when it comes to underwater and marine technology. He just knows everything about this space. And we've been very fortunate that he's been an advisor and helping us with the company almost from the beginning. So really excited to have Justin on board. You know, his bio is very extensive, MIT, etc. But maybe Justin will go into that on his slides. But over to you, Justin, and thank you again for a repeat coming back and doing and sharing your wisdom.
My pleasure. Thanks. And yeah, no pressure. I guess we'll have to, you know, dial up our engagement scores. But yeah, happy to be here. My name's Justin. And as Oliver mentioned, I've been in this space for a while, and I bucket it sort of in an academic setting, spent a fair bit of time at MIT, a government setting as a contractor to NOAA. Then I played the startup game and corporate. These days I work independently. Much of my day job these days is impact investing and philanthropy. So you will see as we converse here, there's a blending of technical innovation and then just sort of the role of business models, investment, and things like that in shaping an industry. So we're going to dive in here. Quick sort of bit of disclaimers, right? So this is sort of a short summary of a long history, and there are lots of clients, colleagues, friends, acquaintances. So you're going to see a ton of pictures, done my best to credit them. Any mistakes I'm making in data and stuff, that's my fault. Apologies. Another comment, this is representative. If I have picked a company A over company B to talk about an idea, that is not necessarily an endorsement. It just happens to be either I have a handy photo or there was recent news about them. So just know that this is meant to be a snapshot and really to give you fresh, timely, key information about what's happening in the field, as opposed to sort of an exhaustive research analysis. So what are we going to talk about? For folks who may be new to the field, going to give you a quick review of what the heck these things are. The highest level acronym we tend to use these days is uncrewed maritime systems. Talk to you about what that means. We'll talk to you about some of the drivers here. What are the activity sets, decisions, events in the field that are shaping this, with a heavy focus on commercial and defense, a little bit of research sprinkled in there. And then a wrap with a focus on some emerging technical innovations combined with some of the most recent notable developments, whether that's investment, mergers and acquisitions. You know, again, it's about to get a sense of what really is making this field go right now and sort of what makes it exciting. So as we walk through, and I promise I'm going to do my very best to leave plenty of time for Q&A, because with all these different topics, I imagine there'll be some measure of like, hey, wait, what? I want to know about that. So we'll come back to that, I promise. Diving in, is one of my favorite little problems in this space, right? You get these acronyms like what's an ASV or a UUV or an AUV or an uncrewed surface vehicle or a ROV, right? You know, there's this alphabet soup, right? We're going to touch on all of this. I'm just going to make one comment here that there's more acronyms. You get government program acronyms. Even this is not exhaustive. So just definitely don't let this overwhelm you and realize that it's just a bad habit of humanity to try to shorten words. But as we dive in, I'm going to fly through several slides. They're all going to look like this. And I try very hard on all these slides. Hopefully you're going to see a photo with a human being and the technology to give you a sense of scale. So these are small uncrewed vehicles. One of the consequences of small is typically they don't go very deep. And their endurance typically is not incredibly long. You know, 8 hours is great, particularly out of a vehicle of this form factor. 300 meters is lovely. You know, something that you can pick up and put under your shoulder, carry out to the water is great. You'll see me reference medium and high precision. That sort of has to do with their ability to carry very powerful navigation equipment. On the surface, life is easy. Underwater, it gets hard. See my prior webinar where I spent a lot of time talking about that. Diverse payloads means not necessarily any individual one of these vehicles has a huge amount of payloads options, but across the spectrum of offerings, pretty much every useful payload, cameras, sonars, samplers, things like that have been deployed and validated. This is a pretty vibrant market. I realize if folks are coming from, say, consumer electronics, a market measured in hundreds of units per year versus millions is not very compelling. But for this space, that's good volume. Prices here, can be below 100K US and certainly can get up to about $500,000. Again, a lot has to do with capability. Some representative manufacturers, Hunton and Ingalls, Seabear, Poseidon's Forge, there are others. But if you want to learn more, those are places to start Googling the field. They get bigger. And these larger vehicles will typically get you to a greater depth. The Teledyne Gavia, the one on the bottom left with the humans for scale, can get to 1,000 meters. They can go longer, 12 hours, maybe 18. These are often used in high precision demanding missions like commercial survey or mine hunting. So they'll have more capable nav systems. Again, lots of diverse payloads. Some of these become very modular. The Teledyne vehicle in particular has little snap lock pieces. It can open and close, and you can put in new bits and bobs. Pretty cool. This market is, 50-ish per year. Bad year might be 10, a good year might be 90, but that's reasonable volume, particularly when you look at these. The low price point here is $500,000. You can easily get over $1 million with high-end sensors. Again, HII, we mentioned. L3 Harris is a player. They're both very defense focused. Teledyne and Eloom are a little more dual use focused. We'll sell into both markets. There are others here as well. They get bigger yet. The large class, and by the way, if you're a military aficionado, there are some specific terms of art, not really using those here. I'm being a little more simplistic. So apologies if my sizing and your sizing don't match. But these larger ones typically will be deployed from a ship. Most of them have the base or option to get as far as 6,000 meters deep, which we call full ocean depth. These are going to have greater endurance, measured in a few days kinds of things, as opposed to a few hours. Very much high precision, and they're doing very important work, often a lot of seabed survey for all the different end users. Again, they've been deployed with most major payloads. This is not a new tech anymore. This market is good sized by volumes when you consider, again, these are starting around $1 million if you're lucky, and probably more like a $5 million investment. So this is a well-established, various competitors. A comment here, right? So Androl is a US company. They're nominally a startup in that they haven't gone public. They're quite large. They bought into this market with the tech you see there, the Dive LD. ELTA, Israeli Aerospace Industries, has come into this market with a little bit of technology by acquisition. Cellular Robotics, bottom left, is Canadian, and Kongsberg, bottom right, is Norwegian, but they've now opened a factory in the US. I'm sharing that as a color commentary on it is a diverse market by supply chain and by customer. We'll talk a little more about that as we go on. They get bigger yet. Here I made a point of trying to find lots of photos with human beings just to give you a true sense of scale. Again, many of these get to full ocean depth. Some of these are designed to go for weeks or months. 5,000 kilometer range is talked about often as an approach. Similar diversity of payloads and precision. On a dollar basis, this is a booming market. We're going to talk a little bit more about that as we get through. There are more vendors than this, but you have a company called the M-Subs out of the UK, top left. That is the first delivered extra large UUV to the Royal Navy. Conveniently or comedically, they called it Excalibur. They certainly have high hopes for this technology in the defense of the UK. Cellular Robotics in the middle there, I mentioned, out of Canada. Boeing started this space with a very, very large vehicle. Zoom in on that small human being. Kongsberg as well has a very large vehicle. So this is a vibrant space. Talk more about market dynamics in a little bit. There's a whole nother class. Everything you just looked at has, it's sort of like a torpedo or an airplane. Moves in a straight line, controls itself the way you might imagine an airplane flies, right? It doesn't stop and hover, doesn't necessarily turn on a dime. This is a whole different category. Gliders work by changing their buoyancy. They get light or heavy. When they're heavy, they sink. When they're light, they float up. And they use control surfaces, therefore, to propel themselves through the water. They're starting to add thrusters. The one in the bottom middle is a new variant from Teledyne that's added some thrusters. All of this is very compelling because these are very long endurance platforms that can stay out for months at a time. They don't necessarily carry the same high precision, high power payloads like a mapping sonar, but they're great for mapping the water column for oceanographic reasons, biology, chemistry, acoustics, listening to what's going on in the world. That's a very powerful area. This is a busy market, easily a couple hundred units a year. Fewer players very active in this market at the moment. There were several, Teledyne and Alcimar. Alcimar is a French company, Teledyne's US. Largely the commercial competitors succeeding at the moment. There is some chewing around the edges from other places and a little more activity we'll talk about later coming out of Europe. There's a whole nother category. This is sort of inspection and intervention leads to a lot more difficulty categorizing. All the stuff on the bottom kind of looks similar, flat, rectangular, longer. These vehicles, you can imagine more like a helicopter. They can move in more different degrees of freedom, up, down, left, right. Then they can, basically do a really cool party trick. Most of these have a docking mode. So you can land on a landing platform. Saab, the Sabertooth, has done this a lot. Freedom does this from Oceaneering, and Saipem as another variant. And why would you do this? Well, this lets you put an asset on a site, say an oil field, and leave it there. And, you want to go take a look at a junction box, at a pipeline pump, at a valve, fire up the robot, leave the garage, go check it out, come back. Very powerful capabilities, pretty well proven. Top left, Nauticus Robotics, newer player on the scene. They're trying to combine that capability with a serious intervention capability where the robot, it's actually basically a transformer. Go find yourself some YouTube videos. It does amazing things. And essentially it moves from this swimming body to this hovering body with arms, manipulators. So this is an amazing space. I call it an emerging market. And in particular, from a volume perspective, the nature of demand here is such that this is probably never going to be 1,000 units deployed because of the way you use it. You put it in sight, it does some work. Maybe you got another site and another site, but just the number of sites where you would install these on a permanent basis is not measured in the many, many thousands. Very cool stuff, though. Highly recommend for some YouTube surfing if you want to learn more. I would be remiss if I did not mention remotely operated vehicles. This is the mainstay of underwater operations, particularly for commercial industry. Smaller units like the video array on the top left, very popular with defense, mine hunting, unexploded ordnance are important applications. Larger units like the one you see on the top right in the launch cage, they do the brunt of heavy labor, installing pipelines, supporting digging of trenches for undersea cables. These are huge demands, very big, powerful equipment. They all have a strength and a weakness, which would be on the bottom left. They run on an armored cable, and that requires this large winch. And apologies, I should have put a person for scale. That winch is bigger than a car. It's a large piece of equipment. So ROVs are great. They're with us. They're not going away. The future is definitely in the untethered and uncrewed autonomous systems. So mention that these are important, but not necessarily a focus. Shifting gears, and we're creeping up on covering this segment, surface vehicles, robot boats. I bin these into two categories. Things that look like boats, have propellers of some form, run on batteries, run on gas engines, and are more easily controlled, usually remotely. So there's a human being available to log in, take command. This is a huge market, booming with dollars, booming with product. These are just a few to try to give you the flavor of both size and function. So some of them are very commercially oriented. Some of them are very military oriented. This is a hot topic we're going to talk more about. There's another category of uncrewed surface vessels and vehicles which are long endurance. Some use solar, some use wind, some combine that. This lets you put a unit out for a very long time and starts to change your cost of operations and access. There are various constraints and limitations to these approaches, but these are becoming quite popular too. Stay tuned for some recent news. All right, there you go. Flew through. There's lots of tech. What's going on? So the next many slides, you're going to see a bunch of photos and a headline. This comes from a product I offer to the market, which is a review of the news in the sector. Comes out every quarter. So I went back to the sort of past 3 quarters, maybe past year. So what's fresh? And you're going to see 30 different things that stand out to me as interesting. My news report covered well over 300. So just know that this is the tip of the iceberg, but it's the neat stuff. All right, we're going to start with defense. We're going to start with Ukraine. You cannot overstate the influence of the conflict in Ukraine on this technology base, in particular on surface vehicles. So if we go back to the beginning of the conflict, we started to hear almost immediately that they've got this new technology. Then before the end of 2022, we're getting YouTube videos and footage of these things in action, doing meaningful damage to their adversary. And then less than a year after the start of the conflict, the opposition has started to use the technology. Right? This is an incredibly quick adoption of a tool. And I will say that, again, this was all pretty much indigenous technology, very innovative, very creative, and certainly influential. So influential such that we start seeing headlines. And again, all these words are headlines on news articles that were published by other people, right? So a year in, changing the way wars are fought. Just after the year in, dramatic efforts to defend themselves. And yet, despite dramatic efforts for defense, you're still seeing success in attacks on the enemy. This was a huge deal in naval warfare. And frankly, it's not exaggeration to say that Ukraine's ability to export by sea depends upon their robotic navy, right? This is a big deal. And now it just keeps going. So more recently, now they've got robot boats that launch robot bombers, right? It's so quick and so innovative and drive. It's a shame. The driver is unfortunate. The innovation is impressive. So much so that now there's a company that wants to market that technology back to global navies, including the US. And now, after all that success with with surface systems, they're now drifting into and developing their own underwater systems. This is important, and it's changing the face of naval warfare for sure. For example, in the US Navy, we look back, again, try to pay, if you're looking at the dates here, right? So now we're talking late last year, US Navy finally went and made a volume buy of USVs from a company called Saronic. One of the things that's sort of subtle here, but important, is this was done under a new transaction authority. So the US Navy, to get their hands on this technology, is changing their approach to procurement. That's non-trivial. DARPA christens the first unmanned ocean-going ship. What does that mean? There have been a bunch of larger ship-sized trials that are quote-unquote uncrewed, no human beings required, but those vessels still maintain all the capacity to support a crew. So they have bunks, they have galleys, they have, plumbing, right? This was the first vessel keel up that ignored all of that and said, we will never put people on this vessel when it goes out to sea. That's important for all kinds of reasons, including manufacturability, cost, etc. So this was a DARPA program, the ship's at sea. I picked another news item, right? There's a reason for this Q4 news item. So CSAT's relatively small, relatively young company, $89 million contract. It came on what's called SBIR Phase 3. Again, if you follow this space, that's pretty cool because the reality of the SBIR program is rarely do programs get to Phase 3. It's all about technology development. But here we're seeing it do its job relatively quickly, and a small company gets a sizable contract. Quick comment, because it is an IDIQ, just don't be fooled. They didn't get a box with $89 million in it. They got a contract worth up to $89 million if they do the work or the customer assigns it. So another point there is this IDIQ contract. Powerful concepts, right? So it's not just about the tech, it's also about how procurement happens. And so what's interesting, and I'm hopping to the middle here, they got the contract and then they raised $20 million in investor capital, right? So it's an interesting state of play that a small company gets attention from the government and then they get attention from investors, which is allowing them to scale and grow more rapidly. That's a very new thing in this field. Popping back up to the top, Anduril, I mentioned, moved into this market. Anduril won an order for a large AUV for the Navy. That was under a specific program. It's an initial order, and it follows what you're going to see on the next slide. Hold your breath. Last comment that I put down here, just this past quarter, Q1, I won't get into it. There's a fair bit of drama about the U.S. Navy's USV procurement plans. There was a thing called MASC. There's a thing called MUSV. The Navy is changing its mind and its strategy on procurement very, very quickly. And in fact, this particular news article was Congress was going to say, remember what I said, you can't have people, spaces on ships? Congress was going to mandate that. They were writing a law to mandate it for a program that doesn't exist now, right? It's just astonishing to watch this interplay of procurement and the idea that we got to move fast. So the U.S. Navy is finally picking up momentum. Meanwhile, globally, I mentioned Anduril, same looking vehicle up there. Australia is buying dozens of these, right? We don't know how many dozens, but what we do know is that contract is worth 1.7 billion Australian dollars. So a little over $1 billion US dollars. This is a huge award, absolutely shaping the field. Remember, the US Navy, after the Australian Navy decided to buy one, right? So the Australians went in and went all in, and then the US Navy said, well, we better buy one of these and figure out what's going on, right? So that's a good trend, at least for Anduril. Another really interesting trend globally, particularly if you are aficionados of the Hunt for Red October and Cold War heritage, the Greenland, Iceland, UK gap for anti-submarine warfare is popular and important again. And this headline says it all. The UK Navy doesn't have enough crewed ships, so their strategy to solve this problem is to go with uncrewed assets. Again, drama, speculation, lots of entertaining conversations around how that's going to get implemented, but it's going to get implemented. Last but not least, for global navies, I mentioned Germany's Navy wants to buy an unmanned arsenal ship. There's two things to note here. So A, Germany getting in on this. Germany does have a meaningful Navy. You know, the Baltic is important and global naval issues matter. What is this thing about arsenal ship? And like, look at that picture. What does that mean? The big trend line here is towards uncrewed vessels that are kind of like a pickup truck, right? They've got a big flat open space in the back. You can carry whatever you need for the job at hand. Snowblower, lawnmower, lawn chairs, mountain bikes, right? What do you want to do? Having a good pickup truck is important. And so one of the ideas is that these containers, you can see a few on the back there, become the payload, and they could become munitions. So the idea of an arsenal ship is this uncrewed vessel with a whole bunch of weapons loaded on the back. That is a trend. It is an idea. They're not quite on water yet, but I expect if we were to do this in a year, you're going to be seeing trials of these things from, again, apparently not just the US Navy, but perhaps the Germans as well. All right, changing gears, defense is the big momentum by money, by demand, but commercial stuff is hugely important in this space. Happens to be a lot of surface vehicles pictured here. It just kind of worked out that way. But this news from Fugro. So Fugro has these uncrewed vessels. They kind of had this funny shape because the idea is that they can be packed up into shipping containers, right? So if you look at that and you squint and you imagine the back of a semi-tractor trailer, that's sort of a shipping container, right? So this USV was designed to be globally mobile. And here you see a pair of them. And one of the things Fugro has been doing very well is getting out there with ROVs tethered to these USVs and doing inspection jobs that they used to have to commission a full-on ship full of people to do. Trunk line survey is this particular example. But the point is that these are becoming routine operations. They're making this tech affordable, reliable, capable. Next one, RoboSys automation retrofit. What's happening here? Whole nother trend is a lot of software and software-focused companies coming on scene. RoboSys automation happens to be one. That's a crewed vessel, and the operators are using it for offshore wind support, and they want to add automation to it. Not saying it's going to ever necessarily be operated with 0 human beings on board, but they want to equip it so that they could. This is kind of the equivalent if you've bought a new automobile recently, right? You're probably being advertised radar-based cruise control, lane keeping assist. There's a lot of reasons you might add automation to a thing that requires a human operator, right? That's very much a trend in the vessel space as well. And this is just one example of how that's playing out. Down at the bottom, Ocean Infinity. Again, we're in a bit of a hybrid mode here. They built this fleet. This is the 14th vessel. And I apologize, there's no people, but you can see the satellite domes. That is a large vessel. It is designed in theory to operate with no crew, and in practice to operate with very few crew, right? So this is the new build version of what I just described. That changes your economics, and that allows you to get a lot more work done for the same budget, which is very important in the commercial scene. So lots of automation and lots of rolling out of new tech in commercial. Last but not least, talk briefly about research. Just a couple of interesting comments here, right? First one, NOAA going out to collect hurricane data with robots. This is not new. It has been happening for several years. Pretty much every prior year, it had been done with sail drone. Sail drone's a robot sailboat. Sail drone is a very large robot sailboat. For various reasons, sail drone wasn't available to do the work this past season, so they turned to the antithesis of sail drone, a little bitty, very small, and I apologize, there's no person, but that's sort of order of a meter long robot sailboat. Pretty interesting turn of events there. CapEx is totally different. Performance is different. Don't get me wrong. I'm not saying 4 little sailboats equals 1 giant sailboat, but it was a whole new approach, and NOAA seems to be, we're still sort of analyzing what's happening, but pretty cool to see agencies evolving and adapting to the field and what's available. A new HUGIN for a university. Why does this matter? The real point here is that the university had a HUGIN AUV. They were doing research with it. Sometimes you go under ice. The AUV doesn't come back, right? There was a point in time where that would have been catastrophic, and the university would never again get any other things to put under the ice, right? There would be judgment that you made mistakes, and now it's just accepted. So the vehicle lost under ice is being replaced because the value of the data, the value of what was learned with the first one was high, and it's just understood that this is something that happens. So I think that's a very powerful trend. You know, we had seen it in other industries, but to see it all the way through into academia is very important. Last but not least, I bring this one up. Obviously, we're here. This is Impossible Metals. This NOAA going out to map. NOAA or any other science or government agency's ability to map the seafloor is absolutely dependent on uncrewed systems. So using AUVs to get good data is the only way they're going to get good area coverage rate. So it's great to see that it's happening. So, all right, I'm cranking along, covered a lot. What's the tech? How did it get there? What's happening? What's new and exciting? You know, what's really shaping things? We're going to capture just a couple of technology stories and just a couple of business stories, and then we can move to some discussion. I'm going to start here. If I gave this webinar and did not put the letters AI in it, I would probably be remiss. I put the letters AI/ML, artificial intelligence, machine learning. There's a healthy amount of skepticism in this community about where those lines blur. So I just bunched them together. Why did I pick this example? I picked this example. This is a surface incident, obviously, right? So this is run by an uncrewed surface vehicle, different kinds of cameras. And in this case, we're looking at marine mammals. These happen to be marine mammals on shore. What I really like about this image is in one snapshot, you can sort of see how a different way of looking at a thing, in this case, there's an island, there's a lighthouse, there happen to be sea lions on it, and different digital views through different digital cameras give you different outputs, right? And I bring that up because it's what enables a lot of new, powerful automated analysis of features. There are undersea equivalents of this as well. It happened to be one I had at hand. And it lends itself nicely to this little discussion, which is one of my favorite dual use AI opportunity sets. What we have going on here is an aerial drone. It is amphibious. It can land on the water, and a USV. The drone is operated through the USV. So the telemetry is going through the USV. So the USV could be using Starlink, high bandwidth satellite telemetry, could be out of sight over the horizon. All right, what do you get out of this? And apologies, there's a lot going on here, but you can see that the drone can see the USV. The USV, you can kind of see it, can see the drone and can see other things. What's really important here is when you're on the surface of the water looking at a feature, let's say a cargo ship that's, a couple kilometers away, you can tell it's a cargo ship. You can't really tell how fast it's going, how big it is, even what direction it's going with one point of view. Once you have two, you can start to employ digital techniques to say, okay, am I looking at the same ship? Yes, I'm looking at the same ship. Okay, now I can see it from two different viewpoints. Now you can derive insights. By the way, this particular photo shoot or image data set is doing it in one place, just from one boat on the surface. That's not what I just described is not what's in that image, but the idea here is concrete. Why does this matter? This is affordable. This lets you monitor things like we've been hearing a lot about, keeping an eye on ships that are going dark, transponders turning off. And this is an entirely passive observation system, right? You're looking at these things with cameras. You're not painting them with radar. So you can really set up a network where you know what's going on. So all of that, it's really the story here is about data fusion and multiple views giving you more data. While we're on the subject, I would be remiss if I did not highlight a startup doing some really cool stuff. Basic idea, I'm sure you've sort of gotten familiar. I want to teach an algorithm to find sharks. So what I have to do is I have to sit there and feed it lots and lots and lots of images of sharks and say shark, 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 not shark, 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 not shark. And eventually it's able to pick out a shark. What this company called On Deck AI has done is they've basically combined the power of video models and large language models. And now what you can do is you can describe the shark. And you can say a shark is, long and skinny and has a pointy fin and has this kind of color. And they can go back and forth and they can say, okay, in this scene, I see a large, long and skinny thing, right? And you see the queries here, right? The query was, how many sharks are in this scene? And the answer is there's 3 sharks. And that answer is coming from an AI tool that has been taught what undersea environments look like using words, right? So this just changes the game on how you make use of ocean data. Let's think about the context of seabed minerals. We're going to find ourselves in an environment where we're going to have data where we haven't seen this data before, right? So we're going to have video data feeding through. And in theory, we can just ask the bot, the AI bot, hey, can you look through that data and find all the stuff you don't recognize, please, right? We've taught you what normal is. Tell us what's not normal. Or can you find all of the features X, all of the sharks, all of the whatever, right? I don't want to oversell this. I don't want to say that this is done and this is perfect, but this is very promising new technology for all manner of uncrewed operations. Another very powerful technology in the space is called eDNA, environmental DNA. Basic idea, if you're a fan of, I'm starting to date myself, but if you remember the TV show CSI, right? You put a sample in a fancy machine, the machine spins around with some dramatic music, and the answer pops out of the machine. Not exactly what's going on here, but sort of. So if you know you're looking for an organism, you can go out and collect a sample of water. And what you're looking at in the bottom right is essentially a full-on biochemical laboratory that's been put on that robot. So it can collect samples and it can analyze samples, and the robot can say, aha, I saw the fish that I'm looking for, or I saw the microorganism that I've been told to look for and programmed to look for. This happens to be in a vehicle called the Long Range AUV that MBARI operates, which could go out for a long time. So when you start to think about how do we monitor the ocean for important features, this technology is going to help us monitor the ocean for biology. And it's very clear that in the not too distant future, It's going to be pretty straightforward to say, I want to make sure I'm watching out for whatever I care about, right? And someone else may decide what they care about, but we're going to have the capabilities to go out there and find things and see things and do it with these uncrewed systems, which will make it affordable to do well. Okay, changing gears from tech to business. I could have spent an hour on this topic alone. Capital and customers are changing the game. Sample one, data point one, Vatten Systems, small, new startup. Maybe they're 2 years old now. I'd have to go back and check out when they were founded. $60 million in a Series A. Why? Because they're building small UUVs that are going to be designed to go fast and or going to be what we call attritable. What does attritable mean? Nobody has quite spelled out the definition, but for me, attritable means it's affordable enough that if it breaks or I lose it early in my ownership experience, I don't mind, right? So it's not designed to be expendable, although this could be, particularly if it carries a payload that goes bang. But if you run it 3 times and then something goes wrong, great. Sort of the opposite if you're following the news of exquisite. You hear the word exquisite come up to talk about a lot of particularly military technology. This is sort of the opposite, right? Anyway, congrats to Vatten. Definitely there's others chasing that same target. Also in 2025, Saildrone. So Saildrone, I haven't spent a lot of time here. They have arguably proven out the business case for long endurance USVs. They've been out on many an open ocean. They've been through hurricanes. They now have vessels painted gray that are doing security, watching for drug running boats, things like that. Last year, the final and obvious step fell into place, and they partnered with a defense contractor. And that photo is literally what's in the press release. So I'm not making this up. They're going to start weaponizing these platforms. It was inevitable. You can decide what you think about that, offline. But the trend here is clear, right? So the industry is pivoting to this market. Another example from the long endurance category down bottom left. So Australia, again, the Blue Bottle USV, and apologies, that photo is not the best, but it's largely another sailing USV, diverse energy, long endurance, good platform. They ordered 40. Remember, we talked dozens of the large UUV, right? This is dozens. The large UUV contract to Anduril was about 1 billion US, about 1.7 billion Australian. This contract is about 176 million Australian, order of 100 million US, depending on the day. I just bring that up to show, so this is technically dozens, that was technically dozens. The surface versus undersea, is it always a 10x difference? No, but it's sort of an interesting thing to note, as is the fact that, the Australians are now going to have dozens of USVs and dozens of UUVs, very quickly. Have a lot of ocean area, totally makes sense, but also shaping how other nations think. Last but not least, this is not technically from last quarter. This is from last 2 weeks. I forget the exact date. I mentioned that company Saronic got a $400 million contract a little while ago. They just closed a funding round at $1.75 billion with a $9 billion valuation on a company that is just over 3 years old and is building robot boats for the Navy. But in that 3 years, they've built hundreds, and they have multiple products, available to build for sale. And they are working hard on that larger USV category I talked about. One of the things I didn't talk about is they bought a shipyard along the way. So very interesting to those of us tracking the field. And then we talk about consolidation, collaboration. In the energy side, Saipem and Subsea 7. All you need to know is this is sort of like, Lexus and Acura are like merging, right? Toyota and Honda are coming together, right? It is a very large mega merger in the offshore energy industry. It's not done yet. Obviously, these things take time, but that's a huge forcing function. What I put here, Q4, Metal Shark and Havoc. Metal Shark is a long-standing, and literally, as you imagine the name metal, they build metal-hulled vessels, police boats, patrol boats. Havoc is a young, again, a couple of years old startup focused on software and autonomy. Those two are coming together to take the old school metal fast boats, new school software, right? That's a trend, and there are several other examples of that. Similarly, bottom left, Helsing is a software-focused autonomy swarm operations company, had no real maritime presence, but they've just moved into it by buying a subsea glider technology company. And so it's sort of in a heartbeat, you all of a sudden have a big company with undersea gliders and software, right? What I'm getting at there is that mixing of dynamics or of industry expertise into large players. Bottom right, just happened really at the end of Q1 announcement. Kraken Robotics buys Covelia Group. Kraken is a Canadian company. They're publicly traded in Canada. They had a couple of really powerful core products relevant to the large AUV industry, which we just talked about. That included undersea batteries and a sensor system called synthetic aperture sonar. They're very strong. So they were selling, I use, this is an overused analogy, but these are the picks and shovels to gold miners, right? They have what everybody building a large underwater vehicle needs. They're doing well. Covelia Group, privately held UK company that came together over the past few years. They have other technologies. They have optical systems, another sonar system, positioning systems, data processing software tools. They're another supplier to that industry. And those two companies came together. That transaction was valued at $615 million US, right? And so a public company ingested, and actually by sort of employee and revenue, Covelia might have been a little bit larger than Kraken. So again, this is big movements, good sized dollar figures. So this is also shaping the industry. Just a last comment on industry trends. The overall cost and complexity of using ocean robots is dropping. Okay, what I'm showing here is not relevant to deep ocean, disclaimer, right? This is shallow ocean, although the USVs can go wherever, right? But you can get an AUV for 100 grand. You can get an ROV, if you don't want to go too deep, order of 10 grand, and the USV's order of 100 grand, right? Some people on this webinar may drive an automobile that cost more than 100 grand. You might have bought it pre-owned 3 years later for a lot less, but originally it was 100 grand, right? I bring that up because it basically makes these exotic technologies much more accessible to many more users. And my favorite example is if you take this solar robot boat, for example, and let's say it's $100,000. And let's say it has a 5-year service life and it spends 65% of its life at sea, right? Or even 50, right? So you get 2.5 years of time on the water for $100,000 capital expense. Over 5 years, the money you will have spent on the human beings involved, because there's always going to be a human being operating it, looking at data, changing batteries, cleaning it off, right? The person and the data. Now, data is going to keep getting cheaper, right? Starlink's going to have competition. But 5 years of human being and data infrastructure, I predict is going to exceed the $100,000 you spent to buy the asset. So the point here on your balance sheet is that your capital expense as compared to your operating expense is declining. I say approaching free. That's unfair. It's never going to be free. But when you start to think about big business, OpEx can outweigh CapEx already. And the hardware trends are going in that direction for this industry. So I think we're going to see even more exciting approaches and ways to think about using hardware. So, to close, what's the deal with ocean robots, right? 2017, The Economist made this claim that data is the world's most valuable resource, no longer oil. We were going into a post-material world. Right now, price of oil, defense and commercial interests are colliding in the Strait of Hormuz. As of this morning, maybe it got better, maybe not. I think we're recognizing globally that it post-material world is not exactly happening. We still need material things. Ocean robots, both commercially and militarily, like this is about it, right? Dual use driver, right? We need the oil. We need the defense to get the oil to flow. Like that just sort of sums it up for me for today at this moment in time. But I don't want to forget The other trend reading about, right? Weather patterns are shifting, right? You see this in your headlines. We're all watching weather, which ties to climate, which ties to research. And is there a super El Nino? And is that going to make the lack of fertilizer because shipping got delayed better or worse? Really important questions on the planetary side. So as I conclude, and we're going to have some time for some Q&A, throughout my 30 years in this space, we've talked about the three-legged stool. And it was looking like Ukraine was going to push the three-legged stool, in this case, over towards the defense leg. And research was going to suffer. Commercial's always, in one sense, been the pillar, right? I put commercial in the middle on purpose because, the commercial industry has always been chugging along, and research and defense have peaks and valleys. Right now, I'm comfortable saying that we're pretty much in that space, right? The volume of units, the dollars, it'll shift back and forth. But this is a really exciting time for the industry because if you want to serve any one of these markets, there are new technologies, new demand signals. If you can find a way to serve all three of these markets without too much complexity on your business side, it's exciting times. So that is my story. I promised time for Q&A. I think we've got time for Q&A, and I'm going to defer back to Oliver to sort of moderate and manage that. I'm at your service.
Thank you, Justin. That was super fascinating. Learned so much, so really appreciate it. Thank you. So anybody that wants to ask questions, please use the raised hand icon at the bottom of the screen, and then unmute yourself and ask. I will ask the first question as I'm here. So the first question is there anything unique coming out of China in this space?
So I'm not going to answer the specifics of unique because I'm going to admit it's hard to really claim total knowledge of what's happening in China. If you're not in that market, it's a little hard. I would say that most of the trends I've talked about technologically, business-wise, are aligned with what I've talked about. I've seen evidence of all the similar kinds of technologies and applications. There are some creative things. There was a news item I didn't put in here, but they basically were building a combination robot boat, robot submarine that was going to go 30 knots, could surface and do. It was like a do everything kind of thing. Pretty sure that was a tech demo, not like a product, right? But there are definitely some creative technology concepts I've seen. And then the other very real thing is you could certainly pull together evidence, public evidence that they are investing heavily in subsea technologies, that they want to have all the same capabilities and capacities ranging from cable laying, pipeline work, seabed minerals. They're obviously very focused on that. We've seen that in these series before. So I don't think that anything I've seen that I would call unique strikes me as an experiment, not a unique focus. But there is no doubt that market and that their capabilities are real, their interests are real, not to be underappreciated.
Great, thank you. Reminder, please use the raise hand. The hand icon is the bottom of the screen, two in from the red hang up, and then unmute. If there are no questions, I'll ask another one. All these unmanned systems need power. What's happening on innovations in power?
Yep, no, that's a great one. There's a handful of answers there. On the surface vehicle side, as we alluded to, there are a number of folks looking at different ways to harness natural energy, sun, wind, wave. Those are all working pretty well. They definitely are functional. You could envision one of those at some scale becoming a mothership to underwater vehicles to recharge them. So that's within physics reason. Underwater, batteries are still important. Batteries are a fascinating problem underwater because of safety concerns. So, for example, if you want to put an asset on a U.S. Navy submarine and it has batteries, that's not trivial. Battery chemistries are arguably not being driven by this industry because by sheer volume demands, battery chemistries are driven by other industries. But there's lots of innovation around the underlying battery chemistry. Some clever but very niche stuff going on with thermal. So the water temperature can be different, hot up top, cold down bottom. There is a drifting float vendor that uses that gradient to make energy. Is there enough energy there to power an underwater robot that propels itself? Probably not, right? So it's an edge case. And then the other definitely thing going on, so fuel cells are very much an emerging trend in these larger underwater vehicles, and that's how you're starting to approach those very, very long ranges. At the end of the day, and it's a bad joke. Sometimes I've joked, like in the U.S. Navy, they come out, we're building bigger and bigger robot submarines. And I'm like, well, why don't you just build robot people and put them inside regular submarines, right? Like, but we're kind of going that way because if you think about the history of submarines, particularly in warfare, diesel electric submarines were the thing, right? And diesel electric is actually a pretty powerful way to make a good-sized submarine system, human-powered or otherwise, have long endurance. And so we're seeing that combination of air-breathing and air-independent propulsion systems inspired by Navy crewed submarines translate into UUVs. So lots going on, hugely important topic. The last thing I'll say about that, if you cycle back to some of the stuff I talked about intervention, UUVs or seafloor resident UUVs, we're definitely at a place where we could drop and in place on the seabed a large garage with lots of batteries, and we could sustain. We have the physics. If the economics justify it, you could just park a lot of energy on the seafloor and manage an operation over time if you wanted. So long-winded answer, great question. I would say that I'm not disappointed that there's not more innovation because it's such a hard problem, and we the ocean crowd typically draw from others on this. So there's a lot of creativity in translation of innovation from other fields.
Reminder, last chance for asking some questions. Aha, great. Ryan, please unmute yourself and ask your question. Yeah, please.
Can you hear me? Sorry.
Yes, we can.
Gotcha.
Thank you. Hi, I'm a mining engineering student from Australia, and we've been having sort of trying to implement autonomous systems in our mining operations through quantum photonics is a big focus at the moment, quantum sensing, all those things, and was wondering sort of that has been being looked at in the marine autonomous vehicle space and how you're managing that. And because also a side note, DARPA contracted Q-Control, which is a company that sort of combines quantum sensing with with computing and then also AI. So I was wondering if there's anything similar in your space. Thank you.
Great question. I would say even more down the TRL scale towards early research than energy. And I think the key consideration there is that, like energy, quantum is a technology being imported into this field. And so I know of at least one startup company that is working on a quantum-enabled LiDAR. So LiDAR is, it's an optical scanning technology, and, they're making some compelling claims about how this new LiDAR enabled by quantum is going to be very special. Very little evidence at the moment. And that's an observation, not a judgment. This is the way it works, right? Powerful tech, powerful ambition, a lot of effort to prove it out. So that's the only specific quantum insertion I'm seeing, with the caveat that, of course, quantum computing generally on the back end, a lot of what we talk about here has huge data sets and huge challenges in interpretation. Many of these fields use very, very large models. So the role of quantum on the data side of this is probably more real than the physical instantiation of quantum in the space. But it is definitely being poked at. You all may be ahead of us in mining.
Great. Paul, please unmute and ask your question.
Yeah, hi. Just to follow up on that a little bit, one of the things that we're seeing with most of these autonomous units is the sheer volume of data that they're collecting and transferring back out. So I heard you talk about Starlink. Is there other systems that are being used, or is everybody pretty much using Starlink? How are we getting these huge data sets back?
Yeah, actually, the field has conditioned itself to not getting raw data back because Starlink is still sufficiently new. So, and I didn't, in my other webinar from a while back, I had a lot of images of data, products, and things like that. What a lot of systems have done is they've trained the asset. They've got edge compute, to use the buzzword, and the assets are delivering analysis and information, not data. And in a lot of cases, the raw data resides on the asset until you physically retrieve it. Good news is we've gotten pretty good at that. So we talked a lot about defense. Defense was the first one. So they call it ATR, automatic target recognition. Like if you know what you're looking for, these robots are pretty good at saying, I saw that thing in the data the way you taught me to see it. So that's been the trend to date. I don't think that trend is going to change because even Starlink and Starlink competitors, right? I was just on an airplane. It had Starlink. It was great, yeah, but it was like 100 down and 3 up, right? And so while I could get what I needed, I sure as heck wasn't going to be transmitting a large data file. And I assume that that's going to remain the trend in that industry. So I think we're stuck with the methodology I just talked about. One interesting thought, though, is I talked about like a garage on the seafloor, right? You could envision either a cable, right, coming up and physical surface connection, or you could also envision little, honest to goodness, little data mules, right? You could envision a swimming hard drive that comes from the seafloor, brings up a month's worth of data, and then you've got your data, right? So we'll see. Great question. Yeah, data, energy, innovation and sensing, these themes have been universal for 30 years, but we're talking about much cooler performance.
Very much so. Great presentation. Thanks.
Thank you.
Well, I don't see any other questions, so I think we should wrap there. We're right on the end of the hour. So again, thank you, Justin. This was wonderful, really insightful. And just reminder to everybody, we will be publishing this probably next week on our YouTube channel and also in our podcast, and yep, look forward to our May webinar coming up.
Right on. And you all can find me on LinkedIn. I'm always happy to chat, very much available in the space. So thanks for the opportunity, and thanks for your time this morning.